might be on that field trip tomorrow. So using rational expressions. The word rational, I just put as a reminder, can be substituted for fraction. Because you see, all of these examples have fractional exponents. And this one really does too. It just doesn't look like that. So if you remember from Algebra 1, the fractional exponents can be written using a radical. Okay? And the form is a to the m over n is equal to the nth root of a to the m. So this fraction tells us the index and the power of what's under the radical. So following that trend, we get that this is the square root. So the 2 is the index. We don't usually write the 2's, but I wanted to this time so that everybody is familiar with where we're going with this. So this is really 36 to the first power. We don't usually write the 1 either. So another way to think of this is just the square root of 36. And the square root of 36 is 6. So basically, this is another way to write the square root of 36. And we can rewrite any radical expression with a rational exponent. And that's what your directions are going to say on your quiz and your test, is to write using a rational exponent. So if we were writing this one using a rational exponent, it would be 343 to the 1/3 power. Now, anybody can plug that into their calculator and get the answer. But one of the things your quiz is going to ask you to do is to simplify this without using a calculator. Now, I'm not going to take your calculator away, but you do have to show your work. So you can use your calculator to figure this out, but you're still going to have to show your work. And the way we're going to show our work is I'm going to start dividing this, because remember, this means that I have to have 3 in my group. So I know that 7 goes into 343 49 times. So as I factor this, this is really 7 times 7 times 7. So the cube root of 7 times 7 times 7 is equal to 7, because the index tells us how many must be in the group. So this is 3 in the group. So this is 7, but the important thing is this is your rationalization. Now again, you can use your calculator to check this, but the work is what I'm going to give you the points for. So yes, you can all type in your calculator the cube root of 343 and get 7, but this is the part that you're going to get the 2 points for, because this question will be worth 2 points. Okay, for number 3. If you're writing this using a radical, the index is a 3, and 125 is actually to the second power. So if we're thinking about this without using a calculator, what we're going to do is write 125 times 125, because that's what to the second power means. And this is all still to the cube root. And 125 factors into 25 times 5. And 125 factors into 25 times 5. And 25 factors into 5 times 5 times 5. And so this is 5 times 5. And that 5 comes down. So again, we're thinking about the cube root of this. So as we talked about, this index means that I have 3 in my group. So this would be 5 times 5, or 25. So the justification for this problem would mainly be this step. If you can show this step, that would be your points for that problem. Now, by all means, plug that into your calculator to check your work, but this is the justification. This is the why. That's number 4. Number 4 is the reason that we have rational exponents. We can simplify this pretty easily. It looks pretty complex. But before we get started, let me remind you that the 20 is not to the 1/2 power, only the x. The 20 would have to be in parentheses for it to be to the 1/2 power. So only the x is to the 1/2 power. So what we have here is 20x, but 20 factors to x, the square root of x, right? So if we were writing this using radicals, this would be the case. Now, it's nice to write it like that, but that's not really very helpful, other than the fact that I can reduce 25ths to 4. But now I have 4, and I'm going to leave this now as x to the 1/2, divided by x to the 1/4. And the reason I'm going to put that using the base and a rational exponent is so that, this is a 4, is so that I can use the laws of exponents to simplify this. Does everybody understand where the 4 came from? So this really means 4x to the 1/2 minus 1/4. It's the same laws of exponents that we were using in the other section. Now they're just fractions. When you divide the same base, that means subtract the exponents. The only difference is now we have to find a common denominator. Well, 1/2 and 1/4 are pretty easy to find a common denominator. 1/2 is 4/8. No, it is 4/8, but I don't need 8s, do I? I only need 4s. How about 2/4? 8 would work, but it's not the least one. So this is 4x to the 1/4 power. Now, if you had to write that using a radical, we would say that it was 4 and the 4th root of x. Okay? Now, if it doesn't specifically say which to put, you get to choose. But lots of times I tell you to write using a rational exponent or write using a radical.